Hi, everyone. I'm going to go through this Chapter 4 practice exam. I'm hoping that you're willing to watch the areas that you need help with. So, we've been on Chapter 4 for a very long time, but there's a lot of key concepts in Chapter 4 that I feel are very important for you to understand. So, let's go through this. Let's go through the answers. For this first problem, you have to use a graphing calculator. Okay, so you can't factor this without using a calculator first. So if you tried to split it down the middle, it's not going to help you. So we're going to use a calculator to be able to get at least 5 points, and then we'll be able to answer the question of what is a local minimum, what's the local max, and then the increasing and decreasing intervals. So we'll talk about that. So let me just write that down. We'll pick up our trusty calculator and we'll go to the y equals screen. Make sure you type it in correctly. So we have x cubed minus 12x squared plus 45x and then minus 56. Okay, so I should be able to get an understanding. Even before I rely on a calculator, I am hoping that you understand this has to be pointing in opposite directions because it's an odd exponent, and the fact that it's going to fall on the left because there is a positive number in front. So if there was a negative, then it would have the mirrored image about the x-axis. Then it would be going up on the left, down on the right. So this makes sense. I'm going to go to my table. I'm going to position my table so that I can at least plot 5 dots, and it looks like I can plot points like -2. I can see it right here. I'm going to do 2, -6. So we're down here. There's a nice dot. We have 3, -2. There's a nice dot. We have 4, -4. There's a dot. And then 5, -6. And we have 6, -2. That's 5 dots. That's all I really can fit on the space provided. So then you need to make sure then you use these points to help you sketch so that it looks like this. We know it's going to point down forever on the left, and we know it's going to point up forever on the right. So we can see that there's a turning point, and then it goes through this point that we said was 4, -4. It'll come down here and then change direction. So there are 2 turning points. This point right here, this is the max. So it's a turning point that's a peak. So this dot right here it looks like it should be 3, -2. So 3, -2, that's your max. This turning point right here is a valley, so it's a minimum, and it looks like it's going to be at 5, -6. That's all. So max and mins are turning points, okay? Don't get confused by other dots that are on this graph. Technically, there's no minimum because it goes down forever. There's no max because it goes up forever, but we can state the turning points. Okay, so now make sure you remember this. When you are stating the increasing, decreasing parts, we must use x values. So we're going to start here way on the left at -infinity. We're going to see that this graph is going uphill. So as I move along the x-axis from left to right, my graph is going uphill from -infinity, and then it's going to stop going uphill when it reaches an x value of 3. So just put it in parentheses. Then it's going to go downhill from this. Now, again, so many people confuse the y values. I don't care that the y value is -2. I am only concerned that the x value is a 3, and it's going downhill from when x is 3 to when x is 5. Okay, so again, it looks like an ordered pair, but that's just the notation that mathematicians agree on. And then it's going to then once again increase from when x is 5 to forever, to positive infinity. Again, you're moving left to right. Okay, that takes care of number one. You're going to have to make sure I already quizzed you on that. So if you look back at your past quizzes, you already answered a question like that. Be ready to answer a similar question on your chapter 4 test. Okay, now here I want to write the rule. So we want to figure out, hey, what rule would I have to type into my calculator so I get this graph? And it's all based on the x-intercepts. So here you need to realize this x-intercept of -2 is a repeat. So on your paper, write it twice. Okay. The only other x-intercept is a +2. Okay. So I'm going to have just one +2. Write the factors then. So if these are my zeros, my x-intercepts, then that means I have x plus 2, another x plus 2 as a factor, and an x minus 2. So then to multiply this, I'm going to keep the x plus 2. I'm going to multiply these two things together. My outers and inners are going to cancel out. So when we do FOIL on this, we're going to end up with x squared, but then your outers and inners disappear, and we're left with -4. Okay. And then the last thing we need to do is simply do FOIL one last time. Again, it makes sense that this is a cubic function because my graphs are pointing in opposite directions, so that when we finally do get an answer, it makes sense that x times x squared is x cubed. I expected to have a cubic function. So we have x times x squared, which is x cubed. When I distribute, I'm going to have a -4x, and inside I'm going to have a 2x squared. So I'm going to write my 2x squared first. I like this in standard form. So 2 times x squared is 2x squared. Then we would have the -4x, and finally -8. Okay, and if you have time on your test, take a couple seconds and type it in at the y equals screen and hit graph, and it should look like the graph that I provided. Okay, so that is number 2. Number 3, this is something that we could have done in chapter 1. It doesn't matter that we're dealing with a polynomial with a degree of 6. The transformations are always the same. So if you see a negative in front, we should know that that is a reflection. And at this level, you only need to say reflection, but it is technically about the x-axis. Okay, we never talked about a reflection about the y-axis. So then here inside, we are adding a 1 to my input. So that is a horizontal movement, and it's to the left one. Okay, think about having to plug in a -1 there. So when you input a -1, you're moving to the left one. Okay, and then this number on the outside, since it's -4, it means it's down 4. Okay, so you'll see some combination of up, down, left, right. It could be a stretch. If I have a number greater than 1, then it's a vertical stretch. If it is a number less than 1, it's going to be a vertical shrink. So just keep that, all the transformations in mind when you do this. So now for number 4, we are going to manipulate a cubic function. So x cubed, we want to first stretch it with a factor of 3. That's super easy. I put a 3 in front. Okay. Then I'm going to move it 7 units up. Okay. So there's your +7. Now, we would be finished, but then I did add one extra movement, and then we want to reflect this whole thing. So again, you could type that into your calculator, but then if I'm going to reflect this, we need to put this whole thing in parentheses and a negative out front. Okay, so then final answer, I'll use g of x. We have negative times 3, which is just -3x cubed. And then we distribute the negative to this 7, and you have a -7. Okay. And I promise you, if you type that in your calculator, it would be following these steps. Okay. So, number 5, super easy. We had a whole section on a quiz. Really, your first quiz in this chapter. I made you do all 4 scenarios. In this case, this is the scenario where I have an odd exponent, so I know my graphs are pointing in opposite directions, and the fact that it's just a positive number in front, I know it's going to fall on the left, rise on the right. That's all I need to see, okay? And again, it's something that we talked about in details throughout this chapter. If you look closely, I messed up number 6, so I had to edit that part out. So this is a long division problem, and you will need to do long division on your chapter for test. It may be a problem where I tell you to use long division and then I'm going to tell you that it's a factor. So if I tell you it's a factor, that means you must get a remainder of 0. In this problem, I don't tell you that it's going to be a factor. So I'm just simply asking to do long division. So where I messed up, I wrote a plus sign and I wrote the wrong problem down. So now I fixed it. So we're dividing by 3x minus 7. So that goes on the outside. We have an 18x squared minus 45x minus 3. So the process, I am hoping that everybody can follow this process. You just have to talk yourself through the steps. We start out by thinking, hey, 3 goes into 18 how many times? Well, 3 fits evenly in 18 6 times. So I put a 6 up top, and then I have an x in the x squared. It goes x times. So I have a 6x up top. Whatever you write up top needs to be multiplied by what's on the outside, and everything should line up for us. So 6x times 3x is 18x squared, and then we get a negative 42x. So then here is a very important part that some people mess up, like during a test. Once you multiply, I would tell you to draw that line, and then we think opposites. I'm going to take my red pen. I'm going to make this a negative 18x squared, and I'm going to turn this into a positive 42x. The x squareds disappear, and I'm left with negative 3x, and I'm going to bring down the minus 3. And then we just have to do this process one more time. It's 3x into negative 3x. Well, that's just simply negative 1. Okay, so then I need to multiply negative 1 times the 3x. It's negative 3x. A negative 1 times negative 7 is a positive 7. I draw my line and I change it to its opposite. So I like using a different color so that I remember that I actually change things to its opposite. And so it looks like we're going to have a remainder of 10. So I'm going to write my remainder over my divisor, and now I am finished. This is the quotient. Okay, so again, long division, just a process that you have to make sure you follow and keep yourself organized. Okay, so now for number 7, this should be an easy problem. I'm just telling you to combine like terms. So we're subtracting and adding polynomials. This first set of parentheses, we're doing nothing. But this next set, realize since we're subtracting this whole thing, I need to change everything to its opposite. So this positive 4x to the fourth becomes a negative 4x to the fourth. This becomes a plus 3x cubed. And then I have a positive 8x to the fifth. Okay. This stays the same. Since it's a plus sign in front of those parentheses, I can just drop the parentheses. And so the game that I'm going to play is I'm going to combine like terms. And I'm going to put this in standard form. So I'm going to start with the largest exponent I see, and I see x to the fifth. So, and that's the only term that contains x to the fifth. So that's my first term I'm going to write. So once I deal with it, I can cross it out. Okay. Then I'm going to look at my x to the fourth power. So this term right here contains x to the fourth. I, again, don't see any other x to the fourth terms to combine it with. So I'm just need to rewrite it. So I'm just going to put it second. Again, then I'll cross it out. My cube terms, it looks like I have negative 7. I have 3 of them for negative 4. But then I also have negative 4 here. So negative 4 minus 4, that's going to be negative 8x cubed. Okay. And then once you're done, you can cross them out. I no longer have to worry about that. And then it looks like I have no squared terms. So it looks like then I go to my x term, and it looks like we have just 2 of them. So 2x, we're done with that. And then the last thing I need to do is just combine 7 and a positive 8 for a 15. That is a pretty, hopefully, easy task to simply simplify. Combine like terms. Get rid of the parentheses, drop the parentheses when necessary, and then combine like terms. Okay? So that takes care of the first page. The second page, This is where we're going to practice that technique of, if I give you a 0, find the other zeros. Okay, so go through, expect 2 of these, 1 or 2 of these on your test. So we're practicing several. So I'm going to quickly put all my numbers inside, and we know this must be a remainder of 0. If it's not, we messed up. So we need to find 3 other zeros. Since it's x to the 4th, I'm telling you -2 is a 0. We need to find 3 others. So let's go through this. I bring down the 2. I multiply, I add, I multiply, I get 18. When I multiply, I get -36. And then when I add, we're going to get a 9. And I feel good about this because -2 times 9 is -18. This is going to be a problem that we're going to factor by grouping. It's a polynomial to the 3rd power that has 4 terms. So we should be able to split this down the middle, and it should work out for us. So let's hopefully get this to work out. Split it down the middle. I factor out an x squared. I'm left with 2x plus 1 inside. So remember, we're not changing the problem. If you distribute the x squared, we're back to these 2 terms here. On the other side, I have to factor out a 9. And the good news is when I factor out a 9, 18 divided by 9 is a 2. So we'd have a 2x plus 1 inside. I feel very good about that because I see it on both sides of my line. So it looks like we have x squared plus 9 as a factor, and we have 2x plus 1 as my other factor. So now when you tell me the problem in factored form, I know I can figure out what makes that 0. So the first 0, we'll just take care of this part. It's going to be a -1/2. So if you would type this into your calculator, it's crossing the x-axis at -0.5 or -1/2. So we have -2, we have the -1/2. We need 2 more zeros. So when you figure out what makes this 0, now again, some of you can do this in your head, you would have to subtract a 9 and take the square root of -9. Okay, when you take the square root of -9, I am hoping you realize it's imaginary. Anytime you take the square root of a negative, it's an I, and the square root of 9 is a 3, so you're left with plus or minus 3i. So there's all our zeros for that problem, okay? Number 9, it looks like we just need to find 2 others. So I'm telling you, -1 is a 0, which means 10, -3, -16, -3 inside. We must get 0. So bring down the 10, multiply, we get -13. When we multiply, we get a +13. When we add, we get a -3. When you multiply, it works out. We will get this +3 here, which results in a remainder of 0. Okay, so then we're left with a quadratic equation. So my suggestion is, if you look at that quadratic and in a couple seconds you realize, hey, I can factor that. That is something I know I can factor. You think in your head, well, there's a 10 in front, so that's that AC method. If you can think, hey, that's not too hard to find the pieces to that. I can solve that pretty quickly by using a -15x and a +2x. Then you can turn this into a grouping problem. You can turn this into a problem just like number 8. If you couldn't figure that out, then use the quadratic formula. The only thing about the quadratic formula is it can be simplified then. Since this could be factored, then I would still want the 2 answers in simplest form. So I'm going to rewrite this so that it's -15x plus 2x minus 3. I split it down the middle. I factor out a 5x, and I'm going to have a 2x minus 3 inside. When I go over to this other side, I already see that 2x minus 3. So that just means we just put a 1 on the outside. We can factor out a 1. Doesn't change the problem, but it does allow us to see that 5x plus 1 is a factor, and 2x minus 3 is the other factor. And when you tell me factored form, it takes a couple seconds to know, hey, there's my 1 intercept. It's -1/5. I'd have to subtract a 1, divide by 5. And then here I would have to add a 3, divide by 2. And the one thing that you can always do on a test, type the original in your calculator and look at the graphs. Okay, -1/5 is -0.2, so it's crossing very close to 0. So it's crossing between 0 and -1, closer to the 0. Okay, so just keep that in mind. It's also crossing at 1.5 because I see my other x-intercept is 3/2, which is 1.5, and it's also crossing at -1. Okay, number 10. This looks like another quadratic that we're going to end up getting. So I tell you 7, and I have 1, -16, 68, and -35. Again, I'm going to cheat a little bit. I know that has to be a 0 there. I bring down the 1, I multiply, I'm going to end up with -9. I multiply, get -63. When I add, I get a 5, and I feel really good about this. 7 times 5 is at 35. So then we have a quadratic that I am hoping you would not waste any time trying to factor. Okay, you can maybe try it, but there's no way you're going to be able to find the pieces that's going to multiply to give you a 5, but add up to a -9. So then we are forced to pick out your A. So there's a 1 in front of that x squared. Your B is a -9. Your C is a 5. And hopefully you have that quadratic formula memorized by now. The quadratic formula tells you to take the opposite of B. So I have a +9 on the outside. Square root of -9 squared. Please make sure you do it as -9 in parentheses squared. Okay, I need a +81 there. So when we calculate it, if you're going to use a calculator, it must know that it's a +81. Minus 4 times my A times my C, which is a 5, all over 2 times 1. So all we need to do then is figure out the discriminant. The discriminant is the number underneath the square root. So I'm just going to rely on my trusty calculator to hopefully calculate correctly. It would help if I actually put in the correct exponent of, now I messed this up, delete, and put a 2. So I have -9 squared, which the calculator will calculate it as 81. It knows to subtract 4 times 5, or 1 times 5. I'll put the 1 in. When I hit enter, I see it's a 61, and I can leave it in that form. I would get a decimal if I tried to clean up the square root of 61. Okay, so that's good enough answer. That counts as both answers with the plus and the minus. Okay, a couple more, and then we are done. So then number 11, more practice with this concept of here is a 0. We need to find 4 others. So this is going to be that quartic. So I will promise you when we find out the equation that we have to solve, it's going to be to the 4th power. So let's put a 1, -4, -43, a 172, a -90, and a 360. So we know it's going to be a -360 at the end there. So bring down the 1, we multiply, and we get 0. This is the one where we have lots of zeros. Okay, when you multiply 4 times -43, we're going to see that it's -172, which again results in a 0. When you multiply, you get 0. You get the -90 here. When you multiply, you do get the -360. So what we're left with is not quadratic. I messed up there, but we'll fix it right there. I won't edit that out. It's x to the 4th. It's 1 less than what we started with. So this 1 results in 1x to the 4th. There's no cube terms. There's -43x squared. There's no x term. There is a constant of -90, and we will solve this and find the 4 remaining zeros. So when you see this, this is an easy quartic. Okay, it can be factored. You can't use a quadratic formula on this. The reason you can't use a quadratic formula, it's not quadratic. Okay, so we are locked in at x squared and x squared. Okay, that's what makes this pretty easy. I also know that this times this is negative 90. It's going to result in having signs that are different, one positive, one negative, and hopefully it won't take you long to come up with ways of getting negative 90 to add up to a negative 43. Well, 45 times 2. And I need the 45 next to the minus, and I need the 2 next to the positive so that my outers and my inners would agree with the negative 43, and they do. So then the last thing we need to do is now figure out. I can kind of do this in my head. I know it's going to be imaginary because I have to subtract the 2, so I'll show it over here. I'm going to subtract the 2 and take the square root. So that's going to result in plus or minus I root 2. Okay, that's 2 of your zeros. For this one, I'm going to end up adding a 45, and then I'm going to take the square root, and I would want you to clean it up. Okay, I'm hoping that you know that 45 is 9 times 5. Square root of 9 is a 3. Okay, so that's where I get 3 root 5 and negative 3 root 5. Okay, the last one is an easy application problem. Okay, it's quadratic. Okay, so we want to make sure that we can still remember how to apply quadratic situations. Again, it really works for any model. Like if you're going to give me a rule, I can make sense of what's happening. So the first thing I'm going to do is simply type this in, and then we need to make sure we understand what your inputs represent and what your outcomes represent. So type in negative 16x squared and then plus 65x and then plus 4. Okay, now looking at the graph's really not going to help us. We just need to know that we're dealing with time. My input is time in seconds, and then we're going to see that the outcome, we see it right here, is the height in feet. Okay, so I'm just going to go to my table. Okay, and you're going to see that when we first start out, this baton is 4 feet off the ground. You say, how do I know that? Well, when time is 0, I have a starting height. I have a starting height of 4, and that's my y-intercept. So you replace this t with a 0, we should know that it's a 4. And that's really the first question. What is the height of the baton when it first leaves the hand? It is 4 feet. Okay, that is your y-intercept. And then it says, what is the maximum height? I'm looking for the vertex. So hopefully I can see it on here. And it looks like we end up getting a somewhere in between this 2 and a 3. So now I'm hoping that you can remember this. Okay, I'm going to be a little bit more precise, but I would allow you to say 2 seconds. Okay, what is the maximum height? It occurs when x is 2. We're going to be right around 70. Whoops, you no longer see that. So to answer this question, but then I'm going to show you how to be a little bit more accurate. But what is the maximum height? According to this table, it peaks at 70, but technically it's a little bit more than that. Because if you remember, let's see if anyone remembers this, the actual line of symmetry is the opposite of b over 2a. So if I look at this rule and I see b is 65, I do the opposite of 65 over 2 times my a. When I calculate that, again, it's going to be something that it is super close to a 2, but it's not quite. 2 times negative 16 is negative 32. So when I do that, I see that it's about 2.03 seconds. Okay, super close to 2, but technically I can put in 2.03 into my table start. And so if I really wanted to know the exact max height, here's how precise I could be. I could say, well, it's not really 70, it's 70.016. But again, just for our purposes here, you can rely on your calculator, look at the table, and just write down this. But I thought I would throw this out to you. And then finally, Let me reset my calculator, start at nice numbers. We can tell that it is in the air. After 4 seconds, it is 8 feet off the ground. By the time we get to 5, it's in the ground. It already hit the ground at 5 seconds. So between 4 and 5. So for this last question, you can say about 4 seconds. Okay. And that's just all table work. We're not solving anything. You're not going to calculate. You're not going to have to use the quadratic formula. It's just an application. And in this case, it's a quadratic application.